right, as far as polynomials are concerned, polynomials are basically expressions with extra condition, with a set of extra conditions. So if I gave you an expression that looked like this, an expression is just the sum of terms. And here's an example of a polynomial. When you test to see whether an expression is a polynomial, what you're looking to check is, are all the powers of variables whole numbers? And so we look to see, here's all the powers of the variable terms. Are these whole numbers? If they are whole numbers, then you have a polynomial. If they're not all whole numbers, then you don't have a polynomial. You just have an expression. And now, if you look at this constant, the constant has an unwritten x to the 0 power. Would that still fit this rule? Is 0 a whole number? Yeah. And so even with your constants, it still fits this rule. If you're looking at the power of this constant, so if I took 9 to the minus 1 power, would that still fit this rule? Yeah, because you don't care about the power of the numbers, just the variable terms, the variable parts of the term. And so in deciding what's a polynomial, you just need to make sure that the powers of the variables are whole numbers. No negatives, no fractions. You can't have a variable in your power. And now, in addition to identifying a polynomial, you'll also be asked to write polynomials in standard form. Standard form for a polynomial simply means you're going to write it from the highest power to the lowest power. So when we look at each of these individual terms, we've already discussed a little bit about degree. And when you're looking at the degree of a term, you're looking at the highest power, right? So what degree term is this first one here? Third. And this one is? Fourth. This one is? 0. And this one is? Second. So the degree of the term is just the highest power. Now, if you have a term with multiple variables, so let's say you have something like this, negative 3x cubed y squared, the degree of this term also may be the sum of powers. Okay, but it's just the sum of powers of an individual term. So when you're looking at something with multiple variables, the degree of this term is going to be what? This is an example of a fifth degree term. Okay, the sum of the powers is 3 plus 2, so there's your degree. Now in this whole expression, this whole polynomial, standard form occurs when you write your terms from highest degree to lowest degree. So if we looked at this expression right here and rewrote it in standard form, the highest degree term is the one with the power of 4, so negative 5x to the 4th, and then the power of 3 plus 3x cubed, power of 2 plus 3x squared, then the power of 1 if there happen to be any. There's no first degree term in this expression, and then the constant will always be last. Okay, so this is called standard form of the polynomial, from highest degree to lowest. If I was asking you to identify the degree of polynomial, okay, which is a similar request as the degree of the term, okay, however, the degree of the polynomial is just going to be the degree of whatever the highest term is. And so it's going to be the degree of your leading term when it's written in standard form. Okay, so in standard form, our highest degree term is 4, so the overall degree of this polynomial is also 4. And so this is a 4th degree polynomial. All right, as far as polynomials go, you may recall if you have a polynomial of a single term, it's referred to as a monomial. If you have a polynomial with two terms, then you're looking at a binomial. If you have a polynomial with three terms, it's referred to as a trinomial. Anything beyond this would be just considered a polynomial. Okay, so here's an example of a monomial. And this would be, with the four terms, is just called a polynomial. All right, so again, one of the things that this brings up is a problem that it's complicated in that it's embedded within a lot of grouping symbols. However, the operations are very simple. Okay, so let's kind of talk through how you can approach this, or how I would suggest you approach it. Okay, obviously, you work from the inside grouping symbols out. Okay, so if we look at this first set of grouping symbols, all the terms are different. Okay, so we don't have to simplify anything. There's a positive in front of it, so we don't have to distribute anything. We're just going to treat those terms individually. Okay, so let's go within the next group of or the next set of grouping symbols. So here, let's combine all of our like terms. Now, as I combine them, I'd suggest that you do it in that standard form. So highest power to lowest power. So looking at the common terms here, our highest degree is a second degree term. So when we combine our second degree terms, we get negative 5x squared plus 3x squared leaves a negative 2x squared. When we combine our first degree terms, we only have the 1, so we can just repeat it. And then to combine our constants, 8 plus 1 is 9. And so here's that blue box all condensed into one. Okay, let's move outside to the next set of grouping symbols here. Okay, and we do have to distribute that negative. So if I bring these terms down, okay, I'm going to distribute the negative through here. And the purple is already written here, so I'm just going to distribute my negative and rewrite everything. And I, again, suggest that you rewrite it in some vertical stacking format that allows you to combine your like terms in a visual way, not just a horizontal combining. So as I distribute this negative, a negative times a negative becomes a positive 2x squared. And so I'm going to put that to the left of the x's. Distribute a negative to the next term, a negative x becomes a positive x. I'm going to write that right below my other first degree term. And then distribute my negative to the 9, we get negative 9. And so now if I combine down these vertical columns, I have a 2x squared, I have a plus 6x, and I have a minus 1. And so now I can go to this very last step. This very last step involves all the terms. So I'm just going to drop down my 3x squared, and I'm going to drop down my minus 5x. Okay, this whole thing has a minus in front of it. And so now when I distribute my negative, I'm going to do the same thing I just did. I'm going to stack these. So negative 2x squared underneath the other second degree term. My negative 6x below the other first degree term. And my negative 1 becomes a plus 1. And so now as I combine down vertically, I have a 1x squared, a minus 11x, and just my plus 1. And so this would be my total simplified form.